Good evening, friends. Today we will discuss about one more important name reaction that is called Wittig reaction. Wittig reaction. Okay, let's come to what is this Wittig reaction? This Wittig reaction is also called Olefination reaction. It is one type of Olefination reaction. What do you mean by olefination reaction? Olefins are also called alkenes. So, Wittig reaction is also called olefination reaction. Okay, in this reaction, carbonyl compounds like aldehydes are ketones. Carbonyl compounds convert to alkenes in presence of Wittig reagent. What is a Wittig reagent? That is none other than triphenyl phosphonium ylide. Triphenyl phosphonium ylide is also called Wittig reagent. In this particular Wittig reaction, triphenyl phosphonium ylide responsible for formation of alkenes. Along with it also forms one byproduct called triphenyl phosphonium oxide. Triphenyl phosphonium oxide is also called triphenyl phosphineoxide. Okay, so what is a Wittig reaction? It is one type of olefination reaction in which carbonyl compounds like aldehydes or ketones convert to alkenes in presence of Wittig reagent called triphenyl phosphonium ylide. So, along with alkenes, it also produces triphenyl phosphine or triphenyl phosphonium oxide. Okay, so this is Wittig reaction. It has very wide applications in our organic chemistry for the synthesis of alkenes. Okay, from many type of carbonyl compounds like aldehydes and ketones. Let us see the overall reaction. For example, it is a well-known carbonyl compound that is called acetone. Acetone in presence of phosphorus ylide. It is a 3-phenyl substituted phosphonium ylide. Triphenyl phosphonium ylide. It produces alkene. Alkene and the oxide form of triphenyl phosphorus. What is this? It's an alkene. What is this? Triphenyl phosphine It is a triphenyl phosphonium oxide or phosphine oxide. triphenylphosphineoxide. So, what is a Wittig reaction? It is one type of alkene preparation reaction. Alkenes are also called olefins. Hence, this reaction is also called olefination. It is a olefination reaction in which carbonyl compounds like either ketones or aldehydes react with triphenylphosphonium ylide to form alkenes and triphenylphosphineoxide or triphenylphosphonium oxide. This is called Wittig reaction. Okay, in this Wittig reaction, you have seen the special reagent that is called triphenylphosphonium ylide. Okay, so this triphenylphosphonium ylide is also called Wittig reagent. It is also called Wittig reagent. Okay, so before going to learn about the mechanism of this particular reaction, you should have to know how to prepare this particular reagent in this particular reaction. Okay, so how to prepare this Wittig reagent? This Wittig reagent can be prepared by treatment of triphenylphosphine. It's a triphenylphosphine with methyl bromide to yield C. It's more electronegative, it's more electropositive. So, you have already studied the substitution reaction. It acts as a nucleophile, attacks onto the electrophile. So, generally, alkyl halides undergo what type of substitutions? Either SN1 reaction or SN2 reactions. Okay, so what type of reaction it is? It's a general alkyl halide undergo SN2 reaction. So, in this particular case, it attacks on electrophilic carbon. So, the bonded electrons shifted to bromine. So, it produces phosphorus, triphenyl, phosphorus made a bond with CH3 plus what is eliminated in this case? Bromides are eliminated. Okay, now what is the charge on phosphorus? Positive charge because it's a loser. Okay, so it's highly unstable. To become stable, it is going to produce one H plus ion to yield triphenyl phosphonium ylide. Triphenyl phosphonium ylide. This is called ylide. What are these ylides? Ylides are nothing but these are containing two different charges or two formal charges at adjacent atoms. See, in this particular case, whenever it is going to remove H plus ion, it produces an intermediate that is called what is the charge here? Negative charge. Here, positive charge. This is called ylide form. Ylides are nothing but these are two different formal charges containing species at adjacent atoms. Okay, such type of intermediates are called ylides. This ylide is highly unstable. It always exhibit in this particular ionic state. Okay, it has both cationic and anionic form. It acts as a nucleophile in the entire reaction. Okay, this particular, due to its high reactivity, it acts as a excellent reagent. It was discovered by a scientist called Wittig. Hence, it is called Wittig reagent. Wittig reagent. This is the way how Wittig reagent is formed. Okay, now we will treat this Wittig reagent with our carbonyl compounds. Okay, now come to the step 1 in this particular Wittig reaction mechanism. Let us see what will happen. It is a carbonyl compound reacted with triphenyl, phosphonium, ylide. Triphenyl, phosphonium, ylide to yield the nucleophilic carbon attacks onto the electrophilic center of carbon of carbonyl compound, thereby the pi bonded electron shifted to oxygen. Yes or no? So now the product is CH3C. Another methyl moiety, oxygen, negative charge, carbon connected with another carbon, CH2 bonded with phosphorus. How many phenyl moieties? 3 phenyl moieties. 3 phenyl moieties. What is the charge here? Positive charge. Just I want to draw the same structure into another format like CH3C, CH3O minus, CH2 phosphorus with how many phenyl moieties? 3 phenyl moieties. 3 phenyl. What is the charge here? Positive charge. Now there is a formation of bond between phosphorus and oxygen to form a cyclic product. That cyclic product containing other than carbon atoms like phosphorus and oxygen. Hence these are called heteroatoms. These heteroatoms containing cyclic product is called heterocyclic product. So here one heterocyclic product is formed. What is that heterocyclic product? Containing oxygen and phosphorus are the heteroatoms. So the name of that heteroatom is oxaphosphetane. What is that? Oxaphosphetane. It is a triphenyl substituted oxaphosphetane. What is this? Oxaphosphetane. Okay, in the step 1, formation of unstable heterocyclic intermediate. What is the name of that intermediate? Oxaphosphetane. That is the heading. Under that, the description is the nucleophilic Wittig reagent attacks onto the electrophilic carbon of carbonyl compound to form a heterocyclic intermediate called triphenyl oxaphosphetane. This is highly unstable. So that's why this particular product undergo further mechanism to yield our products. That is the step 1. Let us see that step. That is step 2, sorry. In the step 1, formation of unstable oxaphosphetane. Step 2, this undergo cleavage to yield our products like alkenes and phosphinoxide. Triphenyl substituted phosphinoxide. That is step 2. Let us see the step 2 mechanism. Okay. The unstable phosphorus with how many phenyl moieties? 3 phenyl moieties. 1, 2, the another one it is 3. Here it is CH2. Okay, this is unstable. What is that? Oxaphosphetane ring. 4-membered heterocyclic ring. Triphenyl substituted. It undergo cleavage. How does it cleave? Which one is more electronegative in this particular case? Oxygen. That's why bonded electrons are taken by oxygen to yield CH3, C, CH3. There is no oxygen between, there is no bond between carbon and oxygen. Yes or no? So, here the charge is positive charge. It already made a bond with whom? CH2, P. Triphenyl substituted. Triphenyl substituted. Am I right? Okay. Now, to compensate this positive charge, the bond between phosphorus and phosphorus and carbon undergo cleaved by heterolytically. Due to more electronegative, carbon abstract the bonded electrons to yield CH3C. Another CH3. What is the charge here? Positive charge. In this particular case, CH2 negative charge plus phosphorus. How many phenyl groups are substituted here? 3 phenyl groups. Made a bond with whom? Oxygen. Sorry, I have forgotten to write positive charge here. Sorry. There is no positive charge. Here, after cleavage of this bond, this phosphorus attains positive charge. Bond with oxygen. What is the charge here? Negative. So, these two are going to produce CH3, C, another methyl moiety. In between them, already existing sigma bond. Now there is a formation of pi bond between them. Our product is formed. What is that? Alkene plus another product. What is that? Phosphorus. Oxide form. How many phenyl groups are substituted here? 3 phenyl moieties are substituted. 1, 2, 3 phenyl moieties are substituted. So, what is this called? It's an alkene. What is this called? It's an oxide. Triphenylphosphineoxide or triphenylphosphonium oxide. Okay. So, this is step 2. Okay. So, with this, Wittig reaction mechanism is over. In this particular Wittig reaction, what is happening? When carbonyl compounds treated with Wittig reagent, they yield alkenes and oxides. What is a Wittig reagent? Triphenylphosphonium oxide is called Wittig reagent. So, how does it form? Wittig reagent is formed by treatment of triphenyl phosphine with methyl bromide to yield triphenyl phosphonium ylide. Triphenyl phosphonium ylide and hydrogen bromide is the byproduct. So that ylide reacted with our carbonyl compound to yield unstable 4-membered heterocyclic ring called oxaphosphetane. That is step 1. In the step 2, 4-membered heterocyclic ring undergo cleavage or oxaphosphetane undergo cleavage to yield alkenes and oxides. Okay. With this, Wittig reaction mechanism is over. Thank you.